Hello, ladies and gentlemen. I'm very happy to be here to share with all of you about the viewpoint on the key technology in optic areas. I think in 20 minutes it will be very short, so I will not go to any details on the technology or to show what's the position of our view on the technology, but I will list what could be the key technologies for future 18 to 36 months. Then all of you can make a choice for your next step. So quick view, we'll see what could be the telco solution or service provider solutions. In first spot, we will see all operators focusing the fiber to the somewhere to a home, especially. Okay, and we can see what could be involved: GPON, and active Ethernet, which is appear today. And I believe in many of the sessions they will talk about details in terms of market or products. But what we needed to look at, I believe, will be next generation PON. And beyond that, we can see two major points we needed to watch. First, what's the backhaul solution for the mobile broadband? The other one, how do we see in the MPLS TP? So this you can see from many of the reports. So what's needed for the speed? So bandwidth and the service requirement drive the technology. So 10G, EPON, GPON. What's the solution we need to apply for? It's a question. But what decide the choice or the selection? I believe we need to go to see where is the install base. So EPON, 10G EPON will drive by the install base, like in Japan or in some other countries. And the GPON, what's the next step? Everyone believes GPON could be the dominant technology. And most of the aggressive operator is in a position to make a choice, even they have an EPON in place. Instead, for sure, GPON dominates everything. In Japan, EPON is everything. Then beyond what it is. In China, we can see they start from EPON. GPON is coming. Then after 2 years, will be. So we needed to look at what to be choose, then make an investment. So it's very depends on what the channel to market. This is a comparison of advantage or the pros and cons. I want to go to detail. Everyone can look at it. So these are services. This is a view how we look at the full PON solutions. So beyond the EPON, GPON, we also look into the WDM PON and the long-reach PON. And something in between is what we call active Ethernet. So open your eye, not only look at these PON solutions. And what's active Ethernet? Everyone believes it's the most attractive one for greenfield operators or some vertical segment. Are we ready to move to active Ethernet? The marketing view, okay. So everyone can see there's an active Ethernet figure in different countries. If you look at active Ethernet, it's very, very European country oriented. So if you are going to develop active Ethernet-based solution, please watch European market. Then, what else we can see? We know we are going to 3G, 3.5G, WiMAX, 3.9G, and 4G. So the narrowband or TDM-based backhaul solution cannot fulfill the needs anymore. There are several solutions. Okay, one is the Ethernet-based solutions. There's a standard ready for this because the challenge will be correct synchronization. So this is the other view. Please take an eye on the mobile backhauling solutions. The other coming standard will be MPLS TP. Okay. This is the convergence of the SDH Sonnet and the MPLS IP into a new view. And we believe this could be a trend for the coming transport solutions. So if you look at optic IP, you are not a G MPLS, you will go to MPLS TP. So this first part about the solutions for telco. The second, we look at the other important segment. That's MSO, or we call cable operators. HFC is well known. Then there's another thing to talk about EOC. We didn't see the success, but we may need to come back to revisit EOC, Ethernet over cable. No. The contribution mainly coming from the maturity of the HPNA as well as the home plug AV. It brings the speed to a acceptable or competitive stage. So if you are familiar with the cable market, please revisit what is EOC for you. And the main market we'll see will be in like China, because policy driven is the importance for this specific market. I want to show the solution. You can look at the chart. The other one is cable PON, or we call eye over glass, I4G. The standards still moving, but a lot of trial, a lot of preliminary product is ready. So this is a kind of PON solution for cable operators. So not only look at HFC, look at EOC, or look at DOCSIS. Come to see what's I4G. You will come in 2 years. Okay. Here's some product view I want to show you. Okay. Then come to something beyond the infrastructure. We talk what is related in our life at home. That the devices we are using. So I look into two major things. One we see as G.HN, next generation digital home standards. It offers a solution to cover different wire connections. So we do believe this G.HN will fly in 18 months. That's my belief. So please, if you are interested in these digital home solutions, don't stay with HPNA, stay on home plug every itself. Start action to look at this G.HN. And the standard was approved last week. It's ITU standard. If you are looking to some downward compatible things, also a supplement from IEEE is there. Okay. The other interesting is the Intel LiPiC. Okay. So they use optic fiber to replace our wire. Okay, this is G.HN. So other application can be applied on top without considering any kind of wire to be used. This is one side from IDB. Yeah, talk about application and services in different domains, computing, CE, or service provider. This is a digester coming from IDF about LiPiC. So you can see optic will be everywhere. And the technology is booming. Standard is developed or underdeveloping. The applications are invented. But who make it happen? We will make it happen. From the chipset vendor, from the system vendor, from the service provider. But look into a lot of technologies. What we should focus on, how to select among the key technology and transfer into the company core technology will be a challenge for us. I do share what my personal observation on the coming optical technologies. And let's work together to see what we can do for next 2-3 years. Yeah. This is my speech. Thank you.
Mr. Zhang, yeah, I'd like to hear your comment about Intel LiPiC. Particularly, yes. I have some reservations. Okay, according to the news announcements, actually, they want to put this LiPiC into like a notebook and yes. all kind of a PC. Okay. However, it's at the 40 gigabits speed.
Yes.
But in the notebook or PC, the bottleneck, the speed bottleneck is not in the transmission. Actually, yeah. Probably more in the CPU and some others. Okay. Could you comment that? So, what's the potential of the LiPiC, particularly the cost, which be pretty higher? Okay.
Yes. Yeah. When I look into this IDF presentation, yeah, my first thinking is, okay, finally we'll go to one single high-speed connection, use fiber. Okay, we know fiber is used beginning in every domain, and it is quite successful for high-class every fiber solution, all of that. But then we try to find what could be a standard can be used in all device connection, especially in the computing environment, like a notebook or desktop. Yeah. The first advantage is solve all the connection, okay? Because we try everything, try USB or whatever, but it never bring a real solution. This is the first time I see a solution with optical fiber-based things for the connection. So it means one type of connectivity for all different interfaces. Okay. So in terms of speed, I think the so-called 40G is just a token, because there is no real need. The important is, okay, this brings a very long-term solutions. We don't need to worry about it will become a bottleneck in the near future. Okay. The second, I assume that speed will not only for one devices, because in the future we talk about cloud computing, we talk about network computing or network devices. So for sure, 100 meter range, we can connect everything together. And the fiber, I believe, will be one of the best solutions, especially now fiber can afford it. So it will solve the concern of the way for the right of way. Yeah. So I will say this is standard two things. One is unify all the connectivity. The second is you will bring a connection through a longer range, means up to 70 to 100 meters. Cost still a concern, but we know cost always go down very fast. Yeah. So I do believe it will come somewhere, unless there is some competitor standard coming. Otherwise, this will fly. That's my point.
Any more questions? Well, thank you very much, Mr. Shane. Very excellent presentation. Now we would like to hear from the next speaker talking about the case for true network transformation with GPON. Ladies and gentlemen, please welcome Mr. Edgar Beckelman, Senior Director, Solutions and Marketing, Wireline Competence Center.
Okay, so I wanted to address two topics. One is about fixed mobile device growth, setting the trend, and the other one is meeting the challenge to actually build a network that can deliver on these promises. So I wanted to share with you these two graphs, and they show a quite remarkable trend. And this trend will actually drive how operators will build networks and how they will deliver the bandwidth that is needed. If you look at the slide on the left, this is actually showing how the number of devices is going to grow. And I use devices in a very broad sense. So any kind of connected device, wireless or fixed, a gaming device, computing device, and it's quite remarkable that the growth is, of course, quite remarkable by itself. But if this is true, we will look at close to 12 billion connected devices, by a short time span by 2013. So you can imagine what will be the impact on your network to serve all devices. And so when I first saw these numbers, I was wondering, there are not even so many people on this planet. So how can we have actually so many devices? And then if you go in more detail, inside there's a lot of, for instance, machine-to-machine devices, where, for instance, operators will put cameras, across the roads. They will take pictures of the cars, of the people, feed these into central databases, and so on. So quite a lot of applications that don't require any humans, but nevertheless will represent a device in the network that will generate traffic. If you look at the right side, this tries to plot a little bit how many devices people will have, households will have in their homes. And each one of you should ask the question, especially those of you who have kids. You would be surprised how many devices you already have, being it a gaming device. Of course, you have your mobile, you have your broadband connection, and so on. And this will grow. Okay, so the challenge is going to be to, as an operator especially, to build a network that is, cost-effective enough, to deliver. And if I look at the next slide, so we of Alcatel-Lucent, we call this the high leverage network. And this graph on the side, I see this a few times in some of my industry partners and competitors. I see that this comes again is where the traffic for sure will grow. There is no doubt about it. But the cost to deliver this traffic growth is going to be a big challenge. So the revenue will grow as well, but we cannot imagine that if, for instance, you as an operator are delivering 5 or 6 times more bandwidth, that suddenly you will be able to charge your subscribers 5 or 6 times. This is not possible. So you will have to build a network that actually can deliver every bit at the most optimized cost, so that basically this traffic does not also represent exponential cost to you, and so that the revenue, although it grows not as big, that you still can make some margin. So the high leverage network, and as we understand it, is actually addressing 2 key challenges. One is of course delivering efficient low-cost bit transport. The other one important is to be able to deliver innovative services. And so it sounds more easier than it is, but it means that you have to have a number of features in your network that allow to build an end-to-end network that actually can cope with the traffic and can easily start adding new services, whatever these services are. So QoS, traffic optimization, and so on, these kind of services. Okay. Oh, sorry. So when we look actually as an HLN, of course, I will focus on the access side. We are trying actually to achieve 3 goals with HLN. One is to increase the bandwidth, and for starters, let's say 50 is the entry point where we should start, and we see already operators in the region have today rolling out services over GPON starting from 200 meg. There's some examples there, but it doesn't stop there. The ambition of some operators is to have 1 giga delivery services, already by 2012, 2013. The second one is to be able to deliver on the convergence in the access, saying that your access network not only will serve on the, for the residential, but also the business, and also will, at the right time, be able to serve the mobile. And then I'm talking about mobile backhaul using GPON to deliver on the, the LTE promise. So again, whenever LTE is going to mature, let's say 2012, it depends a little bit who you ask, we will see a much more balance between what a fixed network can deliver in terms of broadband and what your mobile will be able to deliver. And there must be some balance there, and there will be, of course, a big challenge to aggregate all this traffic to the rest of your network. And GPON there is the most promising technology to do this in a very cost-effective way. And when we're moving to a 10 gig variant of GPON, which we demonstrated recently in Paris, of course, you can imagine that your network will be very well balanced between the fixed and the mobile. Okay. So the 3 points I was mentioning. So first, let's focus on meeting the bandwidth speed requirements. So I've tried to plot here a 2-dimensional graph. One is, of course, today the base technology of a GPON can deliver 2.5 in the downstream, 1.5 in the upstream. So and there is an evolution that's already been announced, being debated very early, I must say. But there is an evolution that will be able to coexist with the 2.5 on the same fiber network, which is called a 10 gig. So of course there will be further evolution, but let's focus on these 2 because they are in the immediate future. On the horizontal one, it is the challenge to deliver the services to more users deeper in the network without increasing your cost. So in Alcatel-Lucent, we have tried to be very innovative in this field, and we are working with different type of optics. So the B+ is the standard optics, but we already are implementing C+ optics and even extended GPON. So you can see here, you can go much deeper in your network, 20 kilometer with the standard, 30 kilometer, 60 kilometer, and also you have increased split ratio, which allows you with 1 feeder PON to address more users. So this will allow you to create more cost-effective networks. And very interesting in this technology and the way we implemented it, you don't need different ONTs. So it's not because you use B+ optics that suddenly your ONTs need also to be plus optics. So they all ONTs can perfectly be connected to any type of this optical technology, which again allows you to be much more cost effective. Okay, so this is, as I said, so here the bandwidth increase, it's a given, and the reach. And this is our strategy in the product. So reaching more users, more cost effective, delivering more speed to them. Okay, now next question is, when we say true fixed mobile conversion, again, and you know, Mr. Chen, you show a very similar slide. In this one, we map a little bit the application. So GPON and then 10G GPON, when it becomes mainstream and more cost effective, will definitely be able to serve the LTE networks very well. So that's why we believe that the GPON will be able to be a good technology to also serve your mobile backhaul when LTE becomes mainstream. Okay, now for mobile backhaul, of course, there are other challenges to meet, and so in three levels of your network. One is at the access size, the ONT size. So that's why we're developing specific ONTs with the right interfaces to interface with your cell site. Okay, it's not indicated here, but protection between the cell site and the central office is of course also a requirement, and a very valid requirement. And then the third requirement is the QoS, okay, because this is most of the time real-time traffic and it has to be served accordingly. And the fourth challenge we have implemented is actually the synchronization, okay, so basically be able to synchronize the traffic that is generated at the cell site with the rest of your network using different technologies like the 1588 version 2. So moving to business access, again, different requirements in this field. Again, at the ONT side, business users, they want, for instance, have a PRI interface to be able to aggregate their PRI, PIBX, and of which in APAC market there is still a tremendous amount of PRI, PIBXs. So in order to bring that traffic over, and then of course devices that offer in the office Ethernet services, also VDSL services. So again, GPON is a perfect with of course the adapted ONT and the adapted feature set will enable you to easily implement those services in your network. Okay, so to conclude, so our vision is really a converged wireline access strategy, and the vision of the high leverage network is actually the cornerstone to realize this one. So basically we are three goals we have in mind with our HLN is, first of all, be able to deliver a scalable bandwidth at the lowest possible cost to your residential users, to your mobile users, and to your business users, okay? Using next generation access, as I said, and innovative optimization techniques, so increasing the speed from 2.5 to 10 gig, allowing to play with different optics to actually deliver that bandwidth to the right place in the network at the most cost optimized way. Secondly is using a converged network to deliver residential, business and mobile backhaul on a single platform, and this is quite important. You remember my first slide shows we will have a tremendous amount of devices, 12 billion was shown there, so the traffic generated by devices will be tremendous and enormous. In order to do something with this meaningful with this traffic, we better have a converged platform to which we can connect all these devices. And then the third is actually putting a lot of intelligence in this network, you know, to create more value. And then I'm talking about specific features to deliver video, synchronization features, features that allow you to aggregate PRI and legacy E1 services, and then you know, and allow operators to use this as a tool and let's say a base for them to create more services to come. So this is my presentation. So if you have any particular questions.
Excuse me, what's your view against what's your view against the EPON or GPON evolution in the future?
So, of course, I don't want to make a case between the two technologies. So, obviously, the GPON and EPON comes from different kind of standardization bodies, and the choice by our company was very early to go with GPON for various reasons, bandwidth reasons, security reasons, and so on. So the focus of our company is really on the evolution of the GPON, and I can't say too much on the EPON. Of course, they are today at 1 gig, and definitely they will have also an evolution path. But our focus is really on GPON, on the optical budget, using the different optics, split ratio, and so on. Only one question.
Any more questions? Well, thank you very much, Mr.
Thank you.
Beckelman. Thank you. Now we would like to welcome the third speaker of the afternoon section, who will be talking about new broadband era with GPON. Ladies and gentlemen, please welcome Mr. Matthias Johansen, Head of Broadband Network South, Greater China, Ericsson.
Thank you very much. Good afternoon, everybody. I will talk then about the new broadband era with GPON. I will not actually talk that much about GPON. I think our colleague here from Alcatel-Lucent had a very good presentation about the GPON and the capabilities of that technology. Instead, I would like to share with you some views from our companies of the driving forces within the FTTX market today. And then I will round up with some comments about GPON as an enabler of that as well. Here we go. So if you look on the market today, what is happening on a global scale, you can say that the market is fundamentally changing. And we can see that many of the driving forces that used to be quite local and only valid in one or fewer number of countries now are becoming global phenomena. I will talk a little bit about that here. We definitely see a transformation of the market. We heard before about the transformation of the network, but I would say that the transformation of the market is equally important, if not even more important, primarily driven by increased competition, new players, new type of operators hitting the market. On top of this, we add the emergence of new business models. And I want to share a little bit later a few words about the open access business model and how we see that evolving and moving forward. I think that these two go very well hand in hand, but they are also to some extent distinctly different. Applications will always be important, right? We're going to build these mega networks catering for hundreds of megabits, if not gigabits of bandwidth down to the end user. So we need to also, of course, to define what are the applications driving these bandwidth demands. I will be talking a little bit about IPTV, and if you're not too tired of that already, we've been talking that for many years. But I think that we see now that things are actually happening in the IPTV space as well. And finally, going back then to network transformation, that we really see is happening in the access layer. And to some extent, you can say that a lot of operators are actually starting their network transformation strategies from the access layer, going then inwards into the networks. Let's start talk a little bit about the market transformation. And I would like to do that by showing a few examples of what is happening in the market. I live and work in China, so for me it's very natural to bring up the China market as a good example of what's happening on the broadband side. As you may know, we've had a huge kind of consolidation and re-engineering of the telecoms operator structure in China, basically with the emergence of three main operators, China Telecom, China Unicom, and China Mobile, having both a fixed, a mobile, and a converged broadband offering. Now this is really interesting, because this is a really good example on how you take a market that used to be quite stable and quite, how shall I say, if not monopolistic, then duopolistic, and you turn it around to make it more competitive. This will bring, and has already started to bring, value to the end users, as well as very strong changes of strategies within these operators. On top of this, and it is not in my slide, but I can add that we also have a fourth player in China, which is SARF, the TV broadcaster and the cable network operator in China, which are having quite advanced plan to move forward also with a broadband offering to residential and enterprise segment. What we see happening in China is really that old, or not old, but true mobile operators such as China Mobile are really forced to become also fixed and converged operators. For instance, in the case of broadband access, I can share with you that China Mobile now has an aggressive plan to deploy fiber to the X, using different type of technologies. But they're also then forced to do this to some extent, because China Telecom, who comes from a very strong fixed broadband background, are now with the acquisition of the CDMA network and the upgrade to 3G, really putting this into use in bundling the service offering to primarily the enterprise segment. So they are basically bundling fixed broadband with mobile services and going for the high-end segment, high ARPU users. And this is really becoming a slight problem for China Mobile, who are then, of course, facing this challenge by deploying their own type of services to become equally competitive. We also see that broadband is really a way to increase the revenue and to grow your ARPU level. And what we've seen over the last couple of years is actually that by innovating the models and by providing more bandwidth, the Chinese operators are able to maintain quite a decent ARPU level. And that is, of course, very important, specifically for a player such as China Mobile. They wouldn't do this unless they really believe there is a business case behind it. That is China. I want to talk about one more example as well, and that is from a totally different part of the world. It's Norway. And Norway is quite an interesting market because in Norway you have a lot of alternative type of operator with a regional or even to some extent a local focus. And they are not only innovating and how should I say, re-energizing the market, but actually becoming a serious threat to the incumbent operator, in this case Telenor. I want to talk and share a little bit about the case study with a company called Lyse Energi. Now Lyse is a utility, it's a regional utility company in Norway who have a telecoms arm that they actually want to grow quite quickly. What they are doing is that they are providing fiber to the home services primarily to the residential segment. They are doing this by building their own infrastructure. They are using a vertical business model, meaning that they provide an end-to-end solution, including the passive network, the active network on top of that, as well as a service layer infrastructure to deploy IPTV services, video on demand, etc., etc. Now Lyse is actually quite successful in this, and they also dare to do something that maybe not the incumbent operators would dare. They dare not to build. So they're very picky with their deployment plans. They are very, how should I say, utilizing a cherry-picking approach, only going for geographical areas that they have a good chance to create revenue and margin in. There are a few key success factors to this case, and part of them are when we've been interviewing and meeting Lyse, they mentioned that really having a vertical model is what works for them. This would be a little bit in contradiction. I will talk about the open access model a bit later on, but this is what worked for them. They also are always benchmarking their competitors, making sure that their service is always top-notch, is always going to be a superior service offering compared to primarily then Telenor. And they grow by franchising this business model. So even though they are a regional company, they can reach whole of Norway, and they can go beyond Norway by franchising the model, and also by sharing some of the technology benefits they have in their platform. Now going forward to the next force that we talked about a little bit before, the business model transformation. This is really about how you optimize the investments that we make in this kind of network, because we all know we spend a lot of capex, or the operators are spending a lot of capex to build the next generation access network. Open access model is nothing new. It has been around for quite a while. It's been quite a successful model in some markets in Northern Europe, such as Denmark and Sweden, and it's also catching on in parts of Asia Pacific. For instance, in Singapore, that you probably have heard of the case of the IDA-driven next generation network in Singapore, as well as in Australia and New Zealand, who are now tendering and trying to define their strategy going forward with next generation fiber access. The open access network, you can look at this type of network from different ways, and one way to look at it is really to say that let companies do what they do best. So a company that is very good at deploying and maintaining a passive fiber network may not necessarily be the company that will be able to run a complicated IT and telecoms environment as an active network operator. In the same sense, you can say that kind of operator who are good at running an active network might not be the one who will be best at innovating a service offering to end users, whether it is residential end users or enterprise end users. So the model, to some extent, is built up around let companies do what they do best. Another way to view it is, of course, to see how can we maximize what we spend on the equipment, and this is kind of more of a macroeconomical perspective, saying that why should we build multiple passive networks? Why one fiber is enough, right? Well, if you say that one fiber is enough, then if you have a vertical business model, then the operator who will build that fiber will then be safe, so to speak, with that end user for many, many years to come. And this is, of course, something that the regulators will be looking at to try to change, and thus trying then to segment the market, saying that if you build a passive plant, you have to share it. And if you build an active network on top of that, you have to share it as well, thus stimulating competition in the service provider segment. Open access, we believe, will become bigger and bigger. We will see I think we will see good case studies coming out, both of Asia Pacific and Europe, that will drive regulators to adopt this business model to some extent. The applications and how to fill the pipe is, of course, a question that is very important. And we talked about IPTV for many, many, many years in this industry. And I think that what we can see now is a little like the revival of IPTV. Now we will really see clear indications that this is taking off and that it is generating money and profit to operators. What we see is that it's 100 of launches, several of the larger operators being actually quite successful. But more importantly, what we see is that end users are actually evaluating or seeing a perceived value in IPTV type of services. So basically introducing time shift TV, long tail TV, high definition, etc., has a clear end user value. And that is, of course, the most important, because that is the way to try to churn end users to adopt an IPTV service, not only by lowering the price, but providing more value. And this is, of course, where we actually can say that operators can make a margin on this, not only being a bit pipe provider for a normal broadcast TV offering. And of course, with IPTV, we believe that going with deep fiber access and transforming your network is the way to do that. That would lead us into access network transformation, actually. So network transformation, I think there is not one single operator who does not have a strategy for network transformation today. I think that the big question is how they will transform and when they will actually start the journey. What we have seen and clear indications of is that this journey actually to some extent starts in the access network, because that has to some extent been perceived as a bottleneck previously. The mathematics is very simple. You push the fiber closer to the end user using different technologies, you can achieve higher bandwidth. So you go fiber to the curb with VDSL2, you go fiber to the building or basement, or fiber to the floor using GPON and VDSL2, or for that matter, fast Ethernet, and you go fiber to the home all the way, providing them 100 megabit plus type of services. The question is, of course, what is most cost efficient to do? And what we see is that operators are actually going in with one strategy, looking at the business case, deploying some tests and trial type of scenarios, and then changing. And the trend today, I believe, is more towards going fiber to the home and actually skipping a fiber to the node, fiber to the curb concept. Specifically when we have, like in Asia Pacific, the fundamental cost benefit of engineering type of work to do that. Again, an example for China. China Telecom has a very aggressive kind of copper out, fiber in strategy. They've always, or not always, but they've had it for quite some time, but we really can see that now it is truly happening, and the number of lines and end users they hook up to the fiber network is actually quite impressive currently. Finally, I just want to a little bit talk about GPON as well as an enabler of all this. We believe that GPON is a good technology to transform your access network. It's a standardized technology. It does IoT quite well, which is a good justification for the operators, being able to, how should I say, always have the most cost-efficient solution. It has an ecosystem that we believe is quite superior in terms of chipset vendors, system vendors, and of course operators adopting GPON as a technology. And it really is a technology that is becoming a global standard and acceptance from all regions and places around the globe. In China, we see that GPON fits very well into the operator models. Whether you want to go fiber to the home, fiber to the office, you want to go fiber to the building, which is actually the preferred model for Chinese broadband operators today, or you want to go more fiber to the curb, fiber to the node architecture and utilize your last 100 or hundreds of meters of copper. On top of this, we see a great drive for fiber to the base station, or GPON to the base station, I should say. So I think that will be the fourth main application scenario that we will see growing in China. With AT&T in the US, we see a similar kind of development. We're engaging quite heavily with AT&T for greenfield type of applications, of course, a fiber to the home architecture they're going for, and for fiber to the for brownfield for existing consumers and customers. They're upgrading the network by providing a fiber to the curb architecture with VDSL2 for the last hundreds of meters. So we believe that there are good case studies to really show how GPON can help operators to transform the network. And I want to leave with a slide just proving what I said about global acceptance. We really see that GPON is taking off globally in major markets such as the US, China, larger operators in Europe, etc. So we truly believe that GPON will add value going forward to an operator's transformation strategy. Thank you very much for listening. That was my presentation.
Ladies and gentlemen, please put your hands together for Mr. Dale Allison, Worldwide Sales VP, Broadband.
Well, good afternoon, everyone. Certainly a pleasure to be here. As I was putting the slides together, one of the things that came to mind was that it is almost exactly 40 years ago today. Actually, it's been a couple of weeks, but 40 years ago, the internet was officially born. It was in Los Angeles. It started out with connecting a system that was at UCLA. And just coincidentally, I was a freshman that year in Los Angeles as an engineering student. So 1969 was a pretty heady year. It was the year we went to the moon. It was the summer of love. It was a lot of different things that happened that year. But for all of us here, I think it represents sort of a foundation that began this industry. I enjoyed the presentation before because I think convergence is one of the things that we've been talking about for at least 20 years. And so today what I'd like to do is talk about maybe more of the mechanics of how we converge. And so let's talk about GPON and what the next generation is happening. So we still have a technology problem. There we go. Yeah, I understand. Thank you. So today what I'd like to do is talk about trends in the technology, talk about in the OLT design, trends in that area. Then we'll also talk about trends in the passive optical network in the ONU design, and just spend a couple of moments on paving the road for 10G PON or next generation PON. There we go. Trapped by technology. So one of the biggest trends we're seeing today in GPON line cards is a movement toward higher density. 1-port, 2-port, and 4-port GPON line cards have been around for the last few years. One of the challenges faced in GPON density is not only how do you get higher density, but how do you get the lowest central office footprint, and how do you lower the power consumption, and also how do you adopt a strategy that you pay as you go. So today, one of the biggest trends that we're seeing in GPON line cards is this movement to 8-port density. The example we show here with SFPs, you can see that again it's a pay-as-you-go type design. So very high density and lower power is a key message. If we look at it a different way and say, how do we reverse the central office power bandwidth and look at it from a bandwidth trend, we can see the evolution of technology over the years, from dial-up technology to ADSL to VDSL, early fiber to the home, and then to GPON. And what we have here is a plot that's very interesting. We see on the left, we see watts per subscriber, and on the right, we see megabits per subscriber. And over the years, as technology has evolved, the power has gone up significantly. One of the things that GPON has brought to the market is that it has lowered the absolute watts per subscriber to just tenths of a watt, and raised the throughput, easily being able to achieve 100 megabits per subscriber. So it really, as we look forward and into technology, and as power becomes more and more critical, GPON is a technology that enables much lower power and higher bandwidth. The other thing that GPON has done is made some significant advances in offering basically better reach and better split power. And so again, we have a chart that we're showing both in the red, we're showing C+ optics, and in the blue we're showing B+ optics. But what this chart really represents is the fact that in today's world, a lot of the initial GPON development has been done in high density areas of population. But there's also a movement that we see not only in North America, but in other rural areas where consolidation of central offices is becoming more important and very much a cost savings to the carriers. And so what this demonstrates is split ratios and how far you can extend your reach. And today we can see with current OLT designs, you can actually extend the range certainly into the 60-kilometer area. And if we look at a 1:16 split ratio, you can get 34 kilometers for B+ and almost 47 kilometers for C+ optics. If we split it to 32, you can still reach a very respectable 24 kilometers for B+ and about 37 kilometers for C+. So again, extending the reach is a critical trend. Again, consolidation of central offices is starting to occur, and GPON is very much an enabling technology to do that. The other thing that GPON has added is the ability to do additional remote diagnostics. One of the classic problems in diagnosing failures is with bended fiber. And many of today's generation of OLTs have added additional features that allow you to detect these types of applications. Some of it relies on the host creating histograms or at least developing a standard database that you can you can check each of the optical nodes. But again, in this example, what we're showing that in a non-bended fashion, here we're showing a 20-kilometer reach with a fiber bend, about a fiber bend of 1 centimeter. And what we're seeing is that in a standard condition, you might have a nominal jitter indication of maybe 11.9. In a bended mode, you would have 6.4. And once it's returned back to normal service, it might still be in that range of 10.6. And it's a way to physically to diagnose where a bend might occur in a fiber. Again, this is critical as we move forward and start getting higher and higher density of installations. The challenge you face is what does a truck roll cost? What does a service call cost? And so the ability to do remote diagnostics that are non-invasive to allow you to better pinpoint and diagnose problems is critical. And again, GPON technology today has really moved forward and added additional diagnostics over and above basic optical diagnostics. So let's talk a little bit about trends in the ONT and residential gateway type designs. I think one of the biggest trends that we see is as we talk about increasing ARPU, I think that was one of the discussions a little bit earlier, is how do you do that? And providing more and more services at the CPE end is becoming important, and we're starting to see that model evolve in carriers around the globe. And so from an architectural standpoint, what does it mean? It means you have to have a lot more intelligence in the CPE device, and you have to have a lot more capability. And you have to be able to do this at wireline speeds. So there's a lot of things that are competing against each other. And so we're seeing that current advanced generation of GPON SoCs are combining network processing with fast accelerators to do the inner working between the upstream and downstream. They do the protocol conversion, and they do header manipulation and a variety of other things. So the architecture to get wireline speed is network processor based, and on top of that, we put a strong microprocessor, and this processor may be running things like Java Virtual Machine. It may run other applications like Django or proprietary software that's being developed and run on the CPE, but it's a microprocessor that it's in the theoretical sense, it's non-invasive on the actual network processor that's actually moving data back and forth. This also gives you the ability to do deep packet inspection which is starting to become more and more important. There were earlier presentations about over-the-top type content, and so how do you, how do you provide QoS? How do you rate limit? How do you do these things? So these are all things that are very important in having a strong microprocessor and also a network processor or multiple network processors inside the CPE. Additionally, in terms of how the system is evolving in the home or at the MDU or at the ONT or ONU, we see a lot of involvement and consolidation and integration of key features. Early in the early 2003-2004 timeframe, we started seeing the PON MAX and the CDR, the clock data recovery circuitry, being combined. Later, we started seeing processors and the MAC CDRs being combined. And today, if we look all the way to the right, we see a single chip, basically system on a chip that is combined not only voice over IP processing, has clock data recovery, has optical diagnostics built into it, has a physical PON PHY that has the burst mode amplifiers and the limiting amplifiers, all included into a single device. And this is quite a technological achievement in being able to do it in a single device. So this is how GPON has evolved over the last several years. The other thing that GPON has done, because again it's an evolving technology, it provides the highest level of integration with the lowest power. And so in this case, what we've done is we've compared EPON from a couple of different sources, and in this configuration, we're saying what is a fiber to the home ONT that has four fast Ethernets, a couple of POTS lines, and what is the power consumption of those major components? And so if we look in this analysis, we see in an EPON type application, it might be between 5 to 6 watts, where if we look in GPON, you're typically going to see somewhere between 1 to 4 watts. So again, from a power consumption and from a long-term, again, thinking about the number of elements you have in the network, it's a tremendous amount of power saving based on the entire network. The other thing that's become very important in the home, I touched on it a little bit earlier about applications and how do you increase ARPU in the home, is what is the strength of the processor that's in the home? And so again, as technologies evolve, the GPON processing system on chips have become more and more powerful. Today, if we look at a current generation of product that's being shipped, you'll see that it's well above 600 dry stone MIPS in terms of its power and performance. That's very dramatic. If you're starting to do, again, more local applications, switching, media awareness, layer 3 type processing, the ability of the microprocessor and the processor itself becomes very important. So you can see the evolvement over time. You can compare some of the EPON chips to GPON, and you see it's much more capable not only for basic ONT, ONU functions, but as the evolvement moves from ONUs into a more robust residential gateway type application, the GPON devices today are much more prepared to handle those kinds of challenges. How do you do it? Well, you do it in a variety of ways. You do, as I said, network processors that run in real time. You use strong microprocessors, but you also take advantage of technology as it moves. And so today, if we look at most of the current EPON technology, it's still in the 180 to 130 nanometer technology, where GPON has been evolving quite rapidly. GPON today, many suppliers are now shipping either 90 or 65 nanometer type-based processors. That gives you the advantage not only of speed, but it also gives you much lower power. So again, GPON is using the most advanced silicon available today. So these are kind of a high-level look at some of the trends in both OLTs and ONUs. Let's spend just a couple minutes and take a look at next generation 10G-PON. If we look, what I wanted to do was give you a forward look and say, what do the costs look like in 2012? And these are industry estimates. And so if we look at both EPON and GPON, we see that they're pretty much at a mature state, and the relative cost between EPON and GPON in this example is very close in terms of their costs. But if we look at next generation XGPON and look at 10G EPON, we can see that there's some dramatic differences. The blue would be the cost of what an ONT would cost, and the red would be the OLT. So we can see that as you move forward in technology, being careful how what you select is going to be very important because of the costs. Another way to look at it is if we look at the SoC, or system on a chip cost, and this is the broad light estimate. GPON today, from an OLT and ONU standpoint, are very, very close, in 2012 will be very, very close, maybe slightly less than what EPON will be. But for all intents, they'll be relatively the same. One of the key elements, though, as you design these devices is how does XGPON versus 10G EPON look? So if we look at the OLT side, we can see that this is a complex chip, but there's still a significant differential from the SoC from an XGPON versus a 10G EPON device, where on the ONT side, it's reasonably close. And again, this is the system on a chip type cost. However, one of the other expenses that has to go into consideration is the optics as well. So if we look at total costs and look at the GPON today using B+ optics versus EPON with PX20, and then look at the next generation, which is XPON and 10 gigabit PON 1010, you can see that there's some dramatic costs. The key is how do these networks coexist? And in this case, we believe that GPON is the only economical solution as you move forward. The other thing that's clear, I think, from FSAN is a very strategic next generation PON roadmap. Coexisting both gigabit Ethernet PON and GPON are very important, I think, for carriers and very important for the industry. These will coexist. The next generation PON, even with a long reach option, will be an overlay of GPON and XGPON via WDM. XGPON meaning from upstream 2.5 gigabits to 10 gigabits and downstream at 10 gigabits. One of the key objectives, of course, is to make sure that the equipment will be as common as possible. And as the standards evolve and as next generation GPON 2 evolves, the key is how do we make these coexist and what are the thresholds and when do these technologies become practical? This is just another way of looking at it in terms of the space. Today in 2.5G PON, we see, as I talked about a little bit earlier, reaches out easily out into the 60-kilometer range with extended GPON well past 60 kilometers. And we see 10G standards moving forward with that also. In process right now is, of course, next GPON 2, which also has the extended reach. If we look at a basic network today, how do these systems coexist? Currently, GPONs are basically 1490 downstream and 1310 nanometers upstream. If we look at it from an overlay standpoint, we can see adding XGPON, how does it coexist? We see that the downstream would be 1580 and with 1270 as the upstream. So the GPON using wave division plexing makes GPON an investment that's very much future-proof, and it also allows it to coexist with the next generation ITU standard PON. Again, another way to look at it is to look at it by spectrum, and we can see below, we can see that the XGPON upstream, where that spectrum is, where the GPON spectrum is, where the GPON down spectrum is, and also for the cable overlay. We think cable TV overlays will be important elements of networks, or at least selected networks in the future, and then we also have the XGPON downstream. So again, using this technology allows all of these systems to work and not interact with each other. Again, most of the ONTs being developed today actually have wave blockers that are already being incorporated that block out 10 GPON streams. So with that, again, today I just wanted to touch on 3 different elements, give the audience at least our view of where the technology is going, see some of the current trends today, and we'll be glad to take any questions if there are any.
Why you consider this function? Because for this kind of function, that means you need to have it's necessary to have a ONT box with the VIP jack inside the box. Otherwise, you cannot fully use your chip.
Yeah, in the case of our specific architecture, in this case we weren't drawing up specific architectures. Our architecture is designed such that not only do we have a microprocessor, but next to the microprocessor we actually have an on-chip DSP that resides inside the chip. So you're actually able to fully take advantage of all the standard audio codes with no performance degradation either in the upstream or downstream or in your actual application processing that you're doing. So that the voice over IP engine runs independently, and so it has no real impact. In fact, it's a significant benefit because you have it all on one chip.
The cost is very level, right? In the cost.
I think in today's market, the cost has been extremely competitive. What you see in most solutions, either a performance degradation in the chip if you don't do it this way, or you have to add an external DSP to do this function. So we've actually taken the DSP function and embedded it on the chip.